All right, so let's give this a try. On your 5-4 part 2 examples, we didn't get to example D. That was what I was supposed to be teaching today. So we're still going to do that. We're going to use half-angle identities to find the exact value without a calculator. So I did give you a formula sheet that has the half-angle identities on them. I wrote it out, put it up on my wall. The first one said to find the sine of 15 degrees. Now, you need your unit circle for this, so get your unit circle out. You need your unit circle. 15 degrees is not on the unit circle. That is because it is a half angle. So we know that 15 degrees is half of 30, right? So the formula for sine, and sine only has one formula, it's supposed to be plus or minus the square root of 1, what is this, minus the cosine of theta all over 2, all right? This is half of theta. If you look again at the formula sheets, this is sine of theta divided by 2. So if 15 is 30 divided by 2. To find the angle we want to put in here, whatever they're giving us, we have to multiply by 2. So 30 is going to be my theta. We're clear? You can't respond. This is strange. Okay, so 30 is going to be my theta. So in the formula, I would have let's see, if 30 is a theta, I'll have the square root of 1 minus the cosine of 30. And it's all over 2. All right? I hope you can see this. Maybe you can zoom in if you can't. But the cosine of 30 is something I know. We know that cosine is the x coordinate, right? So if I look at the unit circle, the cosine of 30 is the square root of 3 over 2. So I will put 1 minus the square root of 3 over 2, all divided by 2, and we need the square root of all of that. All right? You guys remember that since I do not have a calculator, I'm going to change my number 1. I want it to have the same denominator as this fraction over here, so I will change my 1 into a 2 over 2. So I'll have 2 over 2 minus the square root of 3 over 2, and all the rest of the stuff is the same. All over 2, and we have the square root. All right, so now that they have the same denominator, that just becomes a 2 minus the square root of 3. They are both over 2. And I have a 2 in the denominator. All right, I have fractions and fractions. I need to move my board. Fractions and fractions. So what we're going to do when we have fractions and fractions is multiply by the reciprocal or keep, change, flip. So I will keep the numerator as is. I will change this to multiplication. In order to flip this 2 over, I need to make it into a fraction. So I will put a 1 underneath it. And then I will flip that. So what I'll have is 2 minus the square root of 3 over 2. That's what I kept. I'm going to change this division to multiplication. And I'm going to flip this 2 over 1 over. And so now it is 1 over 2. They're still all underneath the square root. Okay? Okay, so then we multiply 2 minus the square root of 3. Since it's all just times 1, it's just a 2 minus the square root of 3. The 2 times 2 on the bottom will give me a 4. I am now just going to separate this. I will give the top a square root and the bottom a square root. Okay, that was that big square root that was here. So I'm square rooting both the numerator and the denominator, and I can do that separately. So we know the square root of 4 is the number 2. And this is just as ugly as it looks. We have the square root of 2 minus the square root of 3. Yep, all underneath the square root. The answer, however, that 2, when you see it on your test and on your test review, they are going to take this out and think of it as a 1/2. Because dividing by 2 is the same thing as multiplying by 1/2. So 1/2, and then this. The square root of 2 minus the square root of 3. That is my answer. Let's see what this looks like.